Angus Creech. Like David, I'm a computational fluid dynamicist and I work in wind and marine energy. I build computational fluid dynamics models of tidal turbines and of wind turbines. This example you see here is from when I built a CGen-like device, which is a dual rotor turbine. The piece of software used can do single or dual rotor turbines. You can take various sort of metrics of the of the blades, and you feed this in, and you can simulate tidal turbines. You can simulate wind farms. You do need a lot of CFD power to do this. You can run this on the supercomputer Archer, so that's quite straightforward for us to do. If you want to see any more information about the wind farm simulations, you can look at that paper at the bottom. And here's the picture you might have seen once or twice before. This is the Lilgrund wind farm. These are vorticity isosurfaces generated by the tip vortices on the tips of the wind turbines. This was a project we did with Vattenfall. We validated this against performance data from the actual turbines. And as you can see, there's quite a lot of complex interaction between all the turbines. So kind of areas of research that would be interesting to look at is looking at the response of downwind turbines to the wakes of turbines upwind, and looking how different atmospheric conditions can affect the performance of the turbines. Now there's one other area that I've just recently been working on. This is a new CFD model of the Sound of Islay. Now what was done here was we created a large domain 35 kilometres north to south and 25 kilometres east to west, and I developed a non-hydrostatic model for modelling the Sound of Islay. Now what non-hydrostatic means is that you have significant vertical mixing and flow. Now if you've ever gone across the ferry, on the ferry across the Pentland Firth, you can see huge upwellings and boils, and it's definitely not hydrostatic. So this model was developed to kind of deal with this. This was a project we did with Scottish Power, and we're validating against ADCP data. Now this model can be used and taken to look at other tidal sites, and this is another possible area. One thing that's quite interesting, if I just skip this through because I don't think I have much time, is you can see these huge tidal jets that come out the south end of the Sound of Islay, and if you can, it's just about appearing here. You get a huge tidal jet that travels out to sea for about 10 kilometres and forms these huge eddy dipoles. And from discussing with other colleagues around Scotland, we've seen that this occurs on various tidal sites. So if that's something you're interested in, then that's something else we could look at. Okay. Now, I unfortunately have to dash off, but you see my email address. If you want to get in touch, if any of these things interest you, please give me an email and we can take it from there. Okay.
This production is brought to you by the University of Edinburgh.